Hello. Today I'd like to introduce you to the HP-8920A RF communications test set. This full-featured service monitor was designed to simplify and speed up radio test and repair. Containing 22 different instruments in a small portable package, the HP-8920A contains the tools you need to support communication systems. The objective of this tape is to give you an overview of the 8920A features and performance and an introduction to basic instrument operation. After viewing this tape, you should have a good understanding for how the 8920 will help you make measurements faster, both on the bench and in the field, and to be able to perform basic measurements. This tape is divided into 8 sections. These include a basic overview of instrument operation, receiver, transmitter, and duplex radio measurements, spectrum analyzer and tracking generator, oscilloscope, signaling encoder-decoder, ease of use features, automatic radio test, and cellular phone test. If you're interested in any particular section, just fast forward to the segment of your choice. Let's begin with a basic operating overview of the 8920A. The 8920 is a CRT-based instrument having screens tailored for the type of testing you want to perform. For radio receiver, transmitter, and duplex testing, there are dedicated keys on the front panel. For example, to configure the 8920 for doing transmitter testing, simply press the TX test key on the front panel, and the 8920 will automatically reconfigure for doing transmitter testing. The other screens in the instrument are accessed in the lower right-hand corner of the CRT in the 2 screens list. Those include RF generator controls, RF analyzer, audio frequency analyzer, scope, spectrum analyzer, signaling encoder and decoder, and the optional radio interface. As with most screens in the 8920, all of the measurements are displayed in large double-sized digits or in bar graph form on the upper half of the CRT. In this case, the 8920 is displaying a SYNAD and an AC level measurement. On the bottom half of the screen are all the instrument settings. For example, RF generator frequency, amplitude, audio frequency and amplitude, and filter selections on the receiver test screen. The inverse video areas are things that you can change. We refer to them as fields. Basic instrument operation is by rotating the front panel knob. Notice as you rotate it, a small cursor moves to each of the fields on the screen. As you rotate the knob, you will feel detents or clicks. Each click is a different knob stop in front of an inverse video area or field. To change the contents of a field, for example, the RF tune frequency, rotate the knob until the cursor is in front of that field and push the knob. That will highlight or select that field. There are 5 types of fields in the 8920. Once you've learned how each of these work, it'll be simple to understand and operate the 8920. The first type of field we'll discuss is the data entry field. The RF tune frequency field we just changed is an example of a data entry field. The contents are changed using the front panel data keys and are generally numeric values. The second type of field is called underlined entry. This toggles the 8920 between the choices listed in the field. An example is the input port on the transmitter test screen. To change from RF in to the antenna port, simply position the cursor in front of that field and press the knob. The underline and the instrument setup will change from RF in out to the antenna port. The third type of field is the list of choices. This is used where you have several different things to choose from. An example is the audio frequency analyzer input. When you rotate the knob to that field and push it, a list of choices is displayed in the bottom right corner of the CRT. To make a change, simply rotate the knob in front of the choice that you would like to select and push the knob. That automatically changes the contents of the field and the instrument. The fourth type of field is called unit of measure. This is used to vary the fundamental units in which a measurement is displayed. An example is a transmitter frequency error shown up above on the upper half of the CRT. To change that frequency error measurement from megahertz to kilohertz, simply position the cursor in front of that field and use the data entry units key, kilohertz, to change it from megahertz to kilohertz. The final type of field is called alphanumeric entry. These are used to enter names or comments in areas such as save recall or titles, which will be output to an external printer. We'll cover those in a little bit more depth in the user features section later on. Let's take a quick look at the input and output connectors on the 8920. On the front panel, there's the high-power RF in-out N-type connector. This port's capable of 60 watts continuous, 100 watts for 10 seconds per minute. It's also capable of full duplex operation for single duplex connections to your radio. Next is the duplex out. The 8920 signal generator can be routed either out the RF in-out or the duplex out connector. This port is used when you need generator output levels greater than -19 dBm, up to +7 dBm. The antenna port is used for sensitive off-the-air measurements, less than 1 microvolt for 12 dB SYNAD on an FM signal. Both of these ports are protected with a micro switch, which opens when levels above 200 milliwatts are detected. These ports will typically endure power levels up to 10 watts without damage to the instrument. The microphone input is used with the 8920 microphone accessory to provide a way to modulate the RF generator with voice. Next is the volume control for the internal speaker and a variable squelch adjustment for the FM receiver. The audio output is used to route one or both of the internal audio generators out the front panel. There are two front panel audio in connectors for floating inputs up to 42 volts peak. The vertical slot is used for inserting memory cards for running iBasic automatic test software. Now that we understand the front panel and basic operation of the 8920A, let's move on to doing some receiving on an FM radio. To configure the 8920 for doing receiver tests, simply press the receiver test key on the front panel, connect the antenna from your radio to the RF in-out connector, and the speaker to the front panel audio in. Next, let's set the RF generator frequency to the center frequency of the receiver of the radio. To do that, rotate the knob until the cursor is in front of the RF generator frequency, push the knob, and key in the center frequency of your radio, in our case 153.0 megahertz. You should now be able to use the internal speaker of the 8920 and listen to a 1 kilohertz test tone. Notice you also have a SYNAD measurement and the AC level measurement being made simultaneously on the top half of the screen. To make a simple receiver sensitivity measurement, simply rotate the knob until the cursor is in front of the amplitude field. Select that field by pushing the knob. Once selected, rotating the knob will increment that field, or that level. So as we rotate the knob, we'll see the level change in 1 dB steps. We'll lower the level until we read 12 dB SYNAD. Approximately there. And you can see that minus 115 dBm is the sensitivity of this receiver. To change the units now in front of that field, we can use the microvolts key in the data entry to simply change from dBm to microvolts. And we can see that the receiver has a sensitivity of approximately 0.4 microvolts. You can also listen to the 12 dB SYNAD signal for quick confirmation that you're really testing to 12 dB SYNAD. If we set the level higher, back to minus 80 dBm, we can also vary the audio frequency to do multiple frequency testing, such as audio frequency response or testing at other than 1 kilohertz. Other measurements are available on the receiver test screen. To access those measurements, position the cursor in front of the SYNAD field, press the knob, and the list available to you are displayed in the lower right corner. You can measure SYNAD, distortion, audio frequency, or DC level. Other functions that are available when making receiver measurements are ref set for making relative measurements, analog bar graph type meter displays, and variable digital averaging. We'll go into those in more detail in the user features section. Now let's move on to transmitter tests. To make a transmitter test on the 8920, simply push the TX test key on the front panel, and the 8920 automatically reconfigures for doing transmitter testing. Hook up the antenna output to the RF in-out of the 8920 and key your transmitter. The 8920 will automatically tune to the carrier frequency and measure power, deviation, and audio frequency. The 8920 can also make a transmitter frequency error measurement by simply changing the tune mode from automatic to manual. You'll notice in the upper left corner of the screen that the transmitter frequency measurement will change to transmitter frequency error. By changing the tune frequency of the RF analyzer, putting the cursor in front of that field, and keying in the center frequency of my transmitter, 153 megahertz. When I key the transmitter again, the transmitter frequency error will read the error from the tune frequency, which is 153 megahertz. The other measurements that are available on the transmitter test screen include SYNAD, distortion, DC level, and DC current measurements. To make a distortion measurement on the 8920, simply position the cursor in front of distortion and select that field. And now we want to vary the microphone level, the input level to the microphone, so that we get rated system deviation for this radio 3 kilohertz. To vary the audio generator level, position the cursor in front of that field, select the knob, and use it to vary the level until you read 3 kilohertz. Now with an input level of 7 millivolts, we're reading a distortion of approximately 50%. The 8920 has audio filtering available to filter off subaudible squelch tones and other types of tones which are coming out of your transmitter and which are causing distortion on this radio, which has a subaudible digital squelch tone, to be very high. You can change your variable filters by selecting filter 1 and going down to the 400 hertz high-pass filter, which will effectively filter off that subaudible tone. And now we're reading the actual distortion of about 2.5%. Next, let's look at making duplex measurements with the 8920. A standard feature of all 8920s is a full duplex mode for testing cellular phones, repeaters, and other radios that transmit and receive on different frequencies. The RF signal generator of the 8920 is fully independent of the RF analyzer and can be offset in frequency from a few kilohertz up to several hundred megahertz. In addition, all of your duplex testing can be done through one port on the RF in-out connector, or you can use the duplex out and antenna input ports for doing two-port measurements using the RF generator and the RF analyzer connected to those ports. Once in the duplex test screen, notice that the same measurements are being made for receiver and transmitter testing, for example, frequency error, power, deviation, and distortion. The audio measurements on the right half of the screen are a function of the AF analyzer input selection. Because we came from transmitter testing screen, the current AF analyzer input is FMD mod. If we were doing duplex testing and wanted to look at the receiver audio input, we simply need to change the AF analyzer input by positioning the cursor in front of that field, selecting it and changing the AF analyzer input to the front panel audio in. Notice when I do that, the 8920 will automatically change to AC level and distortion measured on the front panel audio input. In this way, you can make duplex measurements simultaneously on your transmitter and receiver. Another time saver that you can take advantage of is coupling between signal generator and the tuning frequencies. In many radio systems, the duplex radios have a fixed offset. For example, in the cellular radio band, 45 megahertz. The 8920's generator and receiver can be set up to automatically track in frequency. As you change one, the other will automatically change with you. To configure this offset capability, simply go into the configuration screen, which is accessed through the front panel, Shift, Config, and position the cursor over in front of the RF offset field. By pushing the knob and turning that capability on, and going in and entering in your offset, generator minus analyzer frequency. So, for example, in the cellular frequency band, 45 megahertz. We'll key that in. I'll use the previous key to return to my duplex testing screen. And you'll notice now that the RF generator frequency and the RF tune frequency are offset by 45 megahertz. If I were to tune to the cellular band, say for example 825 megahertz in the tune frequency, notice that my RF generator frequency automatically retunes to 45 megahertz above that frequency, or 870 megahertz. You can also use this feature when using automatic tuning. The 8920 will automatically tune to the transmitter frequency and then set the generator frequency accordingly for your offset for your duplex radio. Next, let's look at the 8920 spectrum analyzer and tracking generator. The spectrum analyzer can be used to monitor the transmitted spectrum from your radio transmitter or used to monitor off-the-air signals. Let's look at an off-the-air signal as an example of the 8920 spectrum analyzer. To access the spectrum analyzer, position the cursor in front of that choice in the two screens area and press the knob. And the 8920 spectrum analyzer display will come up. Next, connect an antenna to your input port. We'll use the antenna input port, the high sensitivity antenna input port, for making our off-the-air measurement. On the spectrum analyzer display, there are 4 levels of controls. We'll show you those. The main controls, which is basic spectrum analyzer operation, the RF generator control for tracking generator operation, marker controls, and auxiliary controls. We'll start off with the main level of controls. First, we'll change the input port from the RF in to the antenna port for making an off-the-air measurement. Next, we'll key in the center frequency of a signal that we'd like to look at. In this local area, the weather channel is 162.4 megahertz. And we'll set an appropriate reference level of minus 30 dBm. Notice now that the signal is displayed on the screen, and if we turn up the 8920 speaker, we should be able to listen to the local weather broadcast. To look at a greater amount of spectrum, we can also vary the span of the spectrum analyzer. Right now it's set at 200 kilohertz. We can vary that to 5 megahertz to look at a larger piece of spectrum and look at other signals that are out there off the air. You'll notice the resolution bandwidth that we're measuring with is displayed on the upper half of the screen, and the resolution bandwidth is coupled to the span, and they change together. The narrowest resolution bandwidth is 300 hertz all the way up to 300 kilohertz for a full 1 gigahertz span on the spectrum analyzer. for more accurate characterization of signals displayed on the spectrum analyzer, the 8920 also has a marker function. Position the cursor in front of the controls field and select the marker position. You can position the cursor by selecting the position field and rotating the knob until the marker is at the peak of the signal you want to measure. In the upper right-hand corner of the CRT, there's a digital readout of the marker frequency and level. In this case, the weather channel at 162.4 megahertz and the level of minus 87 dBm. Other marker functions include marker to peak signal on the screen, marker to next peak, marker to center frequency, and marker to reference level. Now let's use the built-in tracking generator with the spectrum analyzer in the 8920 for making a swept response measurement. For this example, we'll use a radio duplexer to do our measurements. First, we'll take the antenna off of the front panel of the 8920, and we'll connect the antenna input to the duplexer up to our RF generator, and we'll route that out of the duplex output port. We'll take the output of the duplexer and put that back into our antenna input so that we complete our two-port measurement. To use the tracking generator, use the RF generator controls on the spectrum analyzer screen. You can either have a fixed CW RF generator or the tracking generator, so we'll change this to tracking. Next, we'll put in the appropriate amplitude. For the duplexer, minus 10 dBm is good. We'll confirm that the port is out of the duplex port, and our RF generator is now set up to make the swept measurement. Now we'll go up to the main level of controls and verify that the input is on the antenna input port. We'll enter the center frequency of the duplexer, in this case 451.475 megahertz. We'll set the reference level accordingly. We'll set it to the RF generator output level of minus 10 dBm. And we'll increase the span to look at the entire response bandwidth of the duplexer. In this case, 5 megahertz shows it quite nicely. You'll notice that there are 2 notches and that the duplexer is not tuned up. We can take a screwdriver and tune the cavity of the duplexer to maximize the notch response at the center frequency that we want. So by slowly tuning the cavity, I can use the on-screen response to tune the notch to maximum depth at the frequency of interest. Right about there. It's that simple to use the 8920 tracking generator and spectrum analyzer to align filters and tune duplexers. Other features available with the spectrum analyzer and tracking generator include a full offset capability, where the tracking generator and spectrum analyzer can be offset in frequency for doing IF to RF conversions or cross-band repeaters, as well as normal and inverted sweep, where the spectrum analyzer and tracking generator track in different directions in frequency, one up and one down, for characterizing such things as super heterodyne receivers. In addition, using the tracking generator, you still have the same marker capabilities as with the spectrum analyzer, with readouts of frequency and level for measuring the depth of a notch and the center frequency of the notch. In this section, we'll look at the built-in oscilloscope function in the 8920. To give you an example, we'll use the radio that we used before, making transmitter measurements on the demodulated audio. We'll start in the transmitter test screen and key the radio, and then we'll go to the oscilloscope display to look at the demodulated audio. On this particular radio, you remember it has a subaudible digital squelch tone, and we're able to look at the subaudible digital squelch tone directly on the display. The main set of controls on the 8920 are vertical per division, vertical offset, and time per division. They feature real-time update as you vary the sensitivity to both vertical per division and time per division for quickly looking at signals. You'll also notice on the lower left-hand corner of the display the input to the AF analyzer and the input to the oscilloscope is displayed. In this case, the FM demodulation. The audio frequency analyzer input control field controls what the oscilloscope is looking at. And also notice that the display is calibrated in terms of the input that you are looking at. In our example, the level is displayed in kilohertz. If you were looking at an AM demodulated signal, it would be percent AM. And if you were looking at an audio input signal, the display would be calibrated in terms of voltage. The built-in oscilloscope also has the similar type of marker controls that the spectrum analyzer has, such as marker position, where you can vary the marker position along the signal of interest. And in the upper right-hand corner, you get a simultaneous readout of the time and level of the marker, as well as marker to positive peak plus and marker to peak minus. Other functions included in the 8920 oscilloscope include variable triggering, internal and external, auto or normal triggering, continuous or single shot, as well as one full screen's worth of pre-trigger information to capture the leading edges of any signaling bursts or transients that you might be looking at. In this section, we're going to go over the 8920 signaling encoder and decoder capabilities. In order to be brief, we'll go through all of the encoder capabilities and then go through the procedure to set up a simple decoding capability on a tone sequential paging format. To set up the encoder, go to the encoder capability. The first mode that we have available to us is function generator, which includes variable waveforms such as sine waves, square waves, ramps, and triangles. The other modes in the instrument are tone sequential paging format, DTMF, continuous digital squelch, digital paging, AMSyntax cellular, and NMT cellular. To change mode to tone sequential paging, the 8920 has the capability of entering in a symbol sequence, which is the pager address. For each symbol in that sequence, you have variable on times and off times, frequencies, and amplitudes. Your tone burst can be sent out single, a variable number of bursts, continuously, or manually step through one tone at a time. Built into the 8920 are a number of international tone sequential signaling standards such as CCIR, CCITT, EEA, EIA, Euro, Natel, and ZVEI. Simply choose the appropriate standard and the 8920 will automatically update its tones. The next mode that we'll look at is DTMF, or dual tone multi-frequency. Again, you have the capability to enter in your sequence or the phone number. You can vary the relative amplitudes of the high tone and low tone pairs by using the twist field. And each DTMF pair has a variable on time and off time. You can also vary the low tone frequencies and the high tone frequencies if you have a non-standard DTMF type of system. DTMF also has the same type of sending capabilities as tone sequential. The next mode we'll look at is continuous digital squelch system, where you have the capability of entering in your 3-digit hex squelch code. It has a variable data rate, as well as a variable turn-off code time. The next mode is digital paging. Both POXAG and GOLE sequential code paging formats where you have variable data rates, variable function bits, variable pager types, such as tone-only, numeric, and alphanumeric pagers. When testing alphanumeric pagers, the 8920 also allows you to enter in ASCII characters to test the display of your pager, as well as inserting an error bit into the data stream in order to check the decoding capabilities of your pager. The final modes in the 8920 encoder are for cellular radio test. These contain the basic data input and output control fields necessary to initiate a call with a cellular phone and get it up to a voice channel for doing testing. We use this capability in conjunction with the 11807 radio test software. We'll go through 11807 automatic radio test and cellular phone test in sections 7 and 8 of this videotape. Now that we've gone through the encoding capabilities of the 8920, we'll take a brief example of setting up the decoder for making a measurement on this tone sequential transmitter. We'll hook up the radio and go through the 3 steps for making a decoder measurement. Those are manually tune the receiver to the center frequency of the transmitter, manually hold the attenuator to the proper input level, and make sure that the de-emphasis network for your transmitter measurements is off. To step through those, go to the RF analyzer screen. We'll manually tune to the center frequency of the radio, 155.5 megahertz. We'll hold the input attenuator at 40 dB of attenuation, which is good for transmitters from half a watt up to 100 watts. Go to the audio analyzer and make sure that the de-emphasis network is off. That's what's necessary to set up the decoder. And now we'll go to the actual decoder screen to make the measurement. We'll choose the proper mode, which is tone sequential. Make sure that we have the correct standard, which is EIA for this radio. We'll make sure that the input level is correct, and we're actually expecting a 3 kilohertz signal from the radio. And we'll go up and arm the measurement. Notice that the status of the decoder is always displayed in the upper right corner. And now when I key the radio, we've automatically made the measurement. You can also use the speaker to rearm the measurement and listen to the tone sequence coming out. The symbol, the frequency error, on time and off time are all displayed for the tone sequential format shown. For each one of the encoding capabilities, similar decoding capabilities exist for each of the formats. As we mentioned in the introduction, the 8920 was designed to simplify and speed up your test and repair on your mobile radios. In this section, we're going to go through several of the ease of use features that we've designed into the 8920 to help make your testing simpler and faster. The first one of these is a save recall facility on the 8920. You can save an entire instrument setup in non-volatile RAM, and it will be maintained through power down using the save recall facility. Let's first hook up a radio and make a measurement very quickly. We'll do a receiver test on this mobile radio. Where we've quickly set up a SYNAD measurement. Using the save recall facility, we can store this entire instrument setup and recall it in less than a second at any time in the future. To save this setup, press Shift Save. Now what is displayed on the top of the 8920 CRT is an example of an alphanumeric entry field that we talked about earlier in the field types. By scrolling up and down in the list of ASCII characters that are available, you can even name your save recall register. So for example, I will select RX to name this receiver test. Press the Done key, and I've now created a save register for receiver test of my radio. From any other screen, for example, when I'm doing a spectrum analysis measurement, and I want to recall that instrument setup, I simply press Recall, and I have a list of the registers available to me. I choose Receiver Test, and in less than a second, the instrument setup is returned to where it was when I was doing that test. Many times while making a measurement, you want a hard copy of the test results that you've been making. Another useful feature of the 8920 is the hold and print capability. With an external printer connected, you can make your measurement on any screen on the CRT. For example, we'll look at the spectrum analyzer display of the carrier of this transmitter. I can hold that display by using the shift hold function to freeze the display even though the transmitter is unkeyed. And then I can use the shift print capability to dump that graphic image to an external printer. This is an example of the screen print that I did previously on a transmitter measurement for this radio. Several measurement and display functions have been included in the 8920 to make your testing easier. These are accessed through the Data Functions section of the front panel and include ref set, meter, and average. For example, any double-sized digital measurement can also be displayed in an analog bar graph representation. For example, such things as transmitter frequency error. To display that in analog bar graph representation, simply position the cursor in front of the measurement units field, kilohertz, press shift and meter, and you can label your endpoints, the low end, the high end, as well as define the number of intervals, as well as turn a meter on and off. So let's turn the meter on, and we'll get an analog bar graph display of the transmitter frequency error that was currently being measured in a digital readout. The digital readout is also displayed underneath in a smaller character size of the bar graph. For very bouncy measurements, to simulate the damping of an analog bar graph meter, we also have variable digital averaging. For example, on the frequency error, to turn that averaging on, hit Shift Average, key in the number of averages that you want, for example 15, and press Enter. A small annunciator underneath the measurement will tell you that the averaging is on, and you'll see now that the measurement is damped significantly compared to what it was before. Variable averaging is available from 0 averages all the way up to 65,000 averages, so that you can simulate the damping of any analog meter. Another useful attribute is the reference set capability. You can use that capability to make relative measurements on any signal. For example, transmitter frequency audio response using the FM deviation signal. To make an audio response directly on the front panel, simply put the cursor in front of the FM deviation, hit Shift, Ref Set, and Enter to zero that, dB relative to the reading at 1 kilohertz, and then vary the audio frequency directly on the front panel until you can read the 3 dB points directly, 400 hertz, and approximately 3.2 kilohertz on this radio. The 3 dB points are displayed directly on the front panel, and again, an annunciator is underneath that measurement to tell you that ref set is on. Many times it's useful to make settings on one screen and measurements on another. For example, setting up all your transmitter testing using the transmitter test screen, yet making measurements on the spectrum analyzer screen. To quickly toggle between these two screens, simply use the previous key to go between the last screen and the one that you're currently measuring on. If I select my spectrum analyzer to make my measurements, I can toggle quickly between transmitter test and spectrum analyzer in order to make those measurements. Another useful feature of the 8920 are user keys. To access any field without using the knob, you can use user-defined user keys from the front panel. These allow you single button access to any field without rotating the knob. To assign a user key to a field, simply position the cursor in front of that field, hit Shift, Assign, and the user key you want, in this case K1. And you'll notice now that there is a K1 in front of the RF generator frequency field. To assign a user key to the amplitude field, position the cursor in front of it, Shift, Assign, K2, and you'll have K2, the user key K2, assigned to that field. Accessing those fields with one button is as simple as pressing that particular K1. Then you can enter or change that frequency. To move to the amplitude, simply press K2, and you'll move to that field and be able to change it or modify it as you like. There may be times when you'd like to change an instrument setting which is not contained on your current measurement screen. This is very common in stimulus response type testing. For example, varying the RF generator amplitude while looking at the distortion on your audio signal with the oscilloscope. In order to pull a control field to another screen, position the cursor in front of the field or setting that you would like to control, press Shift, Assign, Shift, K1 prime, and the 8920 will tell you that global user key 1 is assigned to the RF generator amplitude field. If we go to the oscilloscope now and look at the audio level, to vary the RF generator amplitude, simply hit Shift, K1 prime, and the RF generator amplitude control field will be displayed on the top of the CRT. Select that and vary the level to watch the amount of distortion on your audio input signal. When you've made the modifications to the settings, simply turn the cursor and the field will disappear. To get it back at any time while you're on that screen, simply hit Shift K1 prime again. 3 global user keys can be assigned at any one time to the instrument. A final user feature of the 8920 is an online help facility. By accessing the help screens, you gain access to up to 40 pages of user information displayed directly on the CRT to supplement all of the information contained in the 8920 operating manual. The 8920 contains a built-in controller that allows it to run automatic radio test programs on cellular phones, mobile radios, and other pieces of communications test equipment. Software allows you to run quick, repeatable test routines to characterize your radios. You can also get a test printout of the results to save as data or hard copy for detailed analysis. Test software is written in HP Instrument Basic or iBasic. You can create your own custom programs, or HP offers a wide variety of pre-written iBasic programs designed to test mobile radios, cellular phones, and other pieces of communications equipment. As an example, we'll run through a brief FM test package. The software is HP-11807, and we'll look at the FM test package, which is contained on a memory card, option 1, North American FM tests. To run the iBasic program, insert the card in the memory card slot of the 8920 and press the tests key to get to the tests screen. The first step in running an automatic test is to define the test sequence and conditions and radio frequencies. This is quickly done with a procedure file. Before you load a procedure, let's take a look at the layout of the various test screens. For now, we're interested in the top third of the screen and several of the subscreens. From this menu, we can define exactly how we want a test to be run. As an example, select the choice Edit Frequency. In this screen, you can enter the transmit and receive frequencies of your radio for up to 50 channels. The other screens you can fill in are for defining the test sequence, specification limits, and radio parameters. While it's possible to fill in each of these screens one field at a time, you can save time by loading a procedure file. In the main test screen, make sure the procedure location is set to card. Move to the procedure field and select it, and you will see a display of any procedure files on that card. In this case, the default North American FM tests, which are shipped with the software. Selecting the procedure file shown fills in the procedure field and updates the test screen with program information and comments on this particular procedure. Now all of the submenus have been filled in. Looking at frequencies first, choose Edit Frequency. If the default frequencies don't match your radio, you can quickly update them to match. Enter the correct frequencies for channel 1, in this case 153 megahertz. Note that you can have separate transmit and receive frequencies, as in the case of duplex radios. Press Edit Sequence to see what tests have been defined. The sequence supplied will do a thorough check of both transmitter and receiver functions using the RX and TX quick tests. To redefine the sequence, let's go in and add 2 more steps. We'll change step 1 to transmitter frequency error, which is test 2. Go to the choose transmitter power, which is step number 3. We can add tests by using the Insert Step key to add 2 more tests. And we'll create a procedure. The tests are microphone sensitivity, and receiver sensitivity. This gives you a few key tests to do a quick check out of your radio. We could also go in and check specification limits and radio parameters, but for now we'll run the test. Let's go back to the test screen. Check your connections between the radio and the 8920. The radio's antenna is connected to the RF in-out connector. For most tests, audio connections are required. First from the radio speaker to the audio in high, and second from the audio out to the microphone input. Select Run Test to start automated testing. If this is the very first time the FM tests are run, there will be a loading time of about 2 minutes while the code is taken from the memory card into the 8920. From then on, there's only a few second delay at the start of each test while the 8920 is being preset. You will be prompted to check for valid channel settings and to key the radio when required. Here, the 8920 is asking you to dekey the radio and press Continue. Change to channel 1, receiver and transmitter frequency of 151.955, which we entered into the frequency table. Key the transmitter, and the 8920 will automatically make frequency error measurements, power, deviation. Dekey the transmitter, set the squelch to minimum. If the audio volume needs to be set for any type of test, the 8920 will display a bar graph to aid you in setting that level. And the 8920 is done with the automated test sequence that we chose. 2 points pass, 2 points fail, with a test time of 74 seconds. The measurements are shown, and if one exceeds the spec limit, a failure will be indicated by the F next to the result. The remaining 2 submenus are used to enter parameters of the radio and the test to be run, and to enter the test limits or specifications that the radio should meet. Note the failure indicated for the transmitter output power test. The default procedure loaded had limits for a medium power mobile, not a handheld. Modify this by selecting Edit Spec. First we'll go back to the main test screen and choose Edit Spec. The table here contains test limits for each of the tests available in the software. Selecting specification number 26 will show the limits that the power measurement was compared to. You can scroll through all of the specifications for each test in the software by rotating the knob and scrolling through the list of specs on the screen. Now just enter the correct limits for your test results. A lower limit of 2 watts and an upper limit of 4 watts. For this test, we check to make sure that the transmitter power is between the two limits, so both is chosen to check. The fourth subscreen is used to enter information about the radio and how the test should proceed. This is done by selecting Edit Parm. Entries into this screen include definition of a radio's audio power, the standard signal generator level used for receiver tests, and limits and step sizes for frequency response tests. Instead of running the test again, let's take a look at the main test screen. Under Test Execution Conditions or Settings that customize the test to best meet your needs. Stop on UUT failure is useful when doing troubleshooting. If the radio fails during a test, the sequence will pause so you can make any adjustments needed to the radio. Then run mode can be set to continuously run, or step one test at a time, to allow you plenty of time to verify results. If output results is set to failures, then you'll get a summary of any and all failures that occur, without lines showing past results. If you have a printer connected to your 8920, you can get a hard copy record that matches the results on the CRT screen. Finally, you can add text to the printout to document key radio or user information in the output heading field. Here's an example printout from the test procedures that we just ran on this radio, showing the pass-fail limit tests and all of the test results. After this brief demonstration of the 8920 and the 11807 radio test software, you can see that automatic radio testing will save you time and give you more accurate, repeatable results when initially checking out a radio or verifying a radio repair. For the final section of the tape, we're going to be reviewing cellular phone testing. Testing a cellular phone is easy with the 8920 and the 11807 automatic cellular radio test software. If you haven't already run through the prior section on automatic radio tests, I would suggest that you go back and review that before continuing on to cellular radio tests. As much of the background that's outlined there is necessary for testing a cellular radio. To load the 11807 software for testing cellular phones, insert the memory card in the front panel. Go to the test screen. Make sure the location is card, and take a look at the procedures on the 11807 software. The option 4 software defaults with 4 different types of procedure files for cellular phone testing. The manual procedure allows you to manually troubleshoot a phone as it gains access to the system. The functional procedure allows you to quickly verify that all sections of the phone are in good working order. The full parametric procedure allows you to perform thorough checks of every aspect of the phone, including audio. The call processing procedure allows you to check all of the call processing and data functions of the phone. The manual, functional, and call processing tests require no audio connections to the phone, but the full parametric testing does require audio connections. Let's start by making a functional test on this cellular phone. This is the most common test a technician would run to verify that the radio is working properly. First, make sure that the antenna connection to the 8920 is correct. Next, select the functional test from the procedure list. Press the Run Test key to automatically load and run the functional test program. The quick functional test will now be performed. This includes a combination of 15 tests with 29 different test points. The functional test takes approximately 2 minutes per phone, with some user interaction required to receive calls and dial a hook flash. Test results are displayed on the screen or to an external printer. The first test conducted under the functional procedure is a registration of the phone. If the phone is unable to register or roam at the start of the testing, check CP control channel under the parameters menu. This should be set to 333 for wireline phones and 334 for non-wireline phones. If set to the wrong control channel, the phone will not register and testing will be aborted. A summary of the test results is displayed on the 8920 CRT. 25 points passed, 4 points failed, with a total test time of 134 seconds. Next, let's go on to manual testing of a cellular phone. To select the manual procedure, go back to the test screen, choose the manual test procedure, and hit the Run Test key. With this test procedure, the phone must first be registered with the system. To do that, press K2, Registration. All of the call processing to register the phone is being sent, and the results will be displayed on the 8920 CRT. Phone number, serial number, and station class mark information are all displayed on the front panel. Once it's registered, the flowchart program steps you through the call processing procedures required to get a mobile onto a voice channel. To page the radio, choose K1 page, and the 8920 will automatically ring the mobile and then expect an answer back to move to a voice channel. Once there, you can initiate handoffs, change of power levels, SAT tones, perform a hook flash, and clear the system. At each stage, all information transmitted by the phone is available for analysis. In addition, all analog parameters are displayed, including power, frequency error, deviation, and SAT tone. If there's a problem with your phone, the manual procedure will help you pinpoint exactly where the problem is occurring during the operation. During testing with the manual program, the program can be paused at any time, and the individual instruments can be used for further signal analysis. The phone will remain on a voice channel while the program is paused. Simply hit the cancel key to pause the program, and from there you can go to any of the other analysis screens, such as duplex, where the measurements are continuously being made for troubleshooting. As with all 11807 software, test specs, parameters, and sequences can be saved as procedures on a RAM memory card. In addition, the results can be printed out to an external printer or saved to a RAM memory card for further data analysis later. We're not going to talk much about base station testing today, but the 8920 is an excellent tool for maintaining and troubleshooting your base stations. Key features of the 8920 for base station maintenance include 1 dB per division resolution on the spectrum analyzer, automatic programming capability for automatic base station test and control, standard duplex test capability, and save recall registers. For more information on the 8920's features for base station testing, please contact your local HP field representative. This concludes the demonstration of the 8920A RF communications test set. By now, you should have a good feel for the basic operation of the instrument, the features and the capabilities, and how you can use them to solve your radio test problems faster, both on the bench and in the field. If you'd like more information about the 8920A, or to arrange for a demo unit, please contact your local HP field representative.